moving on to our next competitor, I'm delighted actually to introduce one of my own students, Olivier Lamarre, who's working with me in the STARS lab, and he's going to talk about the impact of environment uncertainty on long distance navigation on Mars. So Olivier, whenever you're ready, 3 minutes, all yours.
Okay, the top left image here shows the Curiosity rover, one of the few robots that drove on the surface of Mars. A common misconception about these rovers is that they're highly autonomous and can pretty much drive around on their own. The reality, though, is quite different. These rovers rely on human operators to identify dangers around them and tell them where to drive almost every day. Because of this, the distance traveled by these rovers in a day generally does not exceed tens of meters. If rovers could instead drive distances an order of magnitude greater than that in a single day, it would dramatically increase the rate of scientific discoveries about the red planet. So why are we still relying on expert human rover drivers on a regular basis, you might ask? One of the main reasons is that the Martian environment is incredibly complex. If you just take a look at these high-resolution global maps shown in black and white and a surface view of that specific location depicted in this beautiful color panorama, I mean, just look at this. We can see sentients, fields of small rocks and large boulders, shallow and steep slopes, and much more. Rovers often encounter, as you can imagine, terrain that they never or rarely drove on before. And this is where humans excel. Based on their confidence, they can refer to past experiences, identify unknown terrain, and adapt to new unexpected situations whenever they arise. That's actually a key insight. Realizing that the uncertainty we associate with the Martian environment does influence how we tell rovers to behave is the starting point of my research. Is there a way to quantify the perceived uncertainty about the Martian surface? And if so, how should we use those uncertainty estimates to enable future rovers to behave reliably and drive over longer distances? These are core questions that my doctoral research focuses on. Consider this scenario where a rover is trying to reach a distant location that might be several kilometers away. Always staying on familiar low uncertainty terrain might result in inefficient trajectories, whereas tolerating a bit more uncertainty might unveil acceptable alternative trajectories. That's something we've recently demonstrated at a robotics conference workshop using real Martian maps and probabilistic machine learning. We're still in the preliminary phase of this research, and we're collaborating with the NASA Jet Propulsion Laboratory to receive feedback from rover mission personnel and to access actual data collected on Mars. My hope is that I can demonstrate that it is possible to estimate the Martian uncertainty and the Martian environment uncertainty consistently, and in doing so, provide future rovers with the ability to adapt their behavior, drive safely over long distances, and ultimately to increase the rate of scientific discoveries about the red planet. Thank you.